Okay, let me give you guys some more practice now. We are well, you're on a hill which is 90 meters high, which happens to be on Neptune this time. Gravity on Neptune is 11. You're going to fire a cannonball vertically upwards at 43. There's a mini hill here which is 30 meters high. Calculate how long it would take for the cannonball to hit this hill here. Okay, so we're going to fire the cannonball vertically upwards, but and then the minute we fire the cannonball, we're going to retract this cannon as usual. Calculate the total flight time for the cannonball. Okay, so press pause and think about it really, because um uh, well normally you need to work out the maximum height and then jump to the free fall scenario where you ask yourself how long will it take for the cannonball to travel this distance here. Well, anyway, do what you have to do. Find out the total flight time for this cannonball here. Okay, so press pause and have a go. Okay, so the first thing to do is jump to your velocity time graph. So you should have this. Hang on. So you jump to your velocity time graph. This is v here. This is time here. Uh, the initial velocity is 43 meters per second, and as always, you want to find out the time it takes to reach maximum height, because that will give you an idea of what's going on. And then later on, you will need to find out the maximum height, which is given uh, by by the area of this triangle. So let's find out the maximum height, the time of maximum height. So you need an equation for this line here. Well, the equation for this line is given by this. I'm jumping quite a lot, so if you don't understand any of these, then you might have to watch some of the earlier videos. So find out the equation for this straight line, which is given by this. Now at T max here, which is when you fire the cannonball, it reaches T max here, time it takes to get to the maximum height. Well, the velocity here is 0, so you put 0. Well, at time at T max, the velocity will be 0. So you put 0 into this thing here, into this V here. Okay, so it will give you, well, you put 0 into the V here. Okay, so this was your equation here, and then you work backwards to find out the time. So you add 11t to both sides, and then you divide both sides by 11, because 11's gravity on Jupiter, remember, on Neptune, sorry, on Neptune. Um, yeah, so find out the time. So this is the answer here. That's the time it takes to get for. That's the time it takes for the cannonball to reach its maximum height. Okay, T max is given by this. So your velocity time graph now looks like this. Okay, so now you've got yourself T max here. You've got this distance here now. Well, the length of the time here. So now you need to find out the area of this thing here. That will give you the maximum height. Okay, so the maximum height in meters will be the height here times the width here. So the height here times the width here, and then you cut in half. That will then give you the area of this triangle. Now the area represents the height, the maximum height. Okay, H max. So our diagram will look like this. This is our maximum height here. So when we fire the cannonball, it will reach its maximum height at 84.07 meters. Now you would jump to the free fall. You've got to ask yourself, how long will it take for the cannonball to free fall this distance here? But the thing is, what is this distance here? Well, you've got yourself from here to here is the height here, the maximum height, and then you just add this bit. What is this bit here? So if you look at this here, if from here to here is 90, then you get 90, take away 30 here. So this height here will be 60. Okay. So hang on. So this height here will be 60. If from here to here is this, then you basically get this height at 60. Okay, so you are really asking yourself, if a cannonball were to free fall from here to here, which is a distance of this plus this, well, when something's free falling, jump to this. Okay, now you got yourself the height, which is this plus this. Okay, so it's actually this here, which is this bit here, plus the 60, which is this bit here. So that represents the height here. Okay. Well, then jump to this free fall equation. Ask yourself, how long will it take for the cannonball to free fall from here to here? So now just solve t. You merge these two together to give you this, and then times both sides by 2, and then divide both sides by gravity. Gravity is 11, so basically when you're here, divide both sides by 11. That will give you this. Now square root both sides, so that will give you this. So this t here represents the time it takes to free fall from here to here. Okay, so now you've got to add t max here, the time it takes to get to the maximum height. So overall answer, so total flight time equals this 5.12 plus what? T max. T max is this. No, that's height max. Sorry. T max is this. T max is this. Okay. T max is 3.91. So 3 plus plus 3.91. So you're adding the 2. So I'm just going to do this. So 309. So it takes 9 seconds it takes 9.03 seconds to hit this bit here. So this time here will be T max, and then you've got to add it to that thing. So the overall answer will be this. Okay.